Hi, everyone. I'm Ian Miller, Coastal Hazard Specialist at Washington Sea Grant, and I was also the lead author for updated sea level rise projections for Washington State, released in 2018. My presentation today is intended to provide you with a brief primer on sea level rise in Washington State that is based on that work that was done as part of what we call the Washington Coastal Resilience Project. This NOAA-funded project was intended to accelerate planning to enhance coastal resilience in Washington. Now, today I'm going to focus on three things. I want to first define what we mean when we talk about sea level rise, briefly talk about the global processes that connect climate change to sea level, and then finally describe what we should expect here in Washington and point you to where you can find out more for your particular area of interest. So let's start first with the question, what is sea level rise? What exactly do we mean when we use this term? So by way of defining what sea level rise is, I'm going to start here with a view of some data you may already have quite a bit of familiarity with. These are water level data collected every 6 minutes at the Seattle Tide Gauge, which sits right at the ferry terminal in downtown Seattle. And in this case, I've plotted these data in feet relative to mean lower low water. And I've chosen a single week at the very end of 2018 to visualize. And the key thing that jumps out at us when looking at these data are the very clear high and low tides that occur every day. And note, that the water level varies quite a bit, 13 feet or more over this particular time period. We're very accustomed here in Washington to these large daily tidal swings, but of course, this isn't sea level rise. So to try to get at that, next, I'm going to show you the exact same data, but I'm going to zoom out to the entirety of a year. Here, note that the y-axis hasn't changed, but with this view of an entire year, a few interesting things emerge. For example, we can clearly see here periods in which the high tides are a bit higher and low tides are a bit lower. These are the spring and neap tidal cycles driven by the relative orientation of the sun, the earth, and the moon. However, this still doesn't get us at what sea level rise is. So next, I'm going to show you these exact same data, except instead of showing you all of the data, again, this is water level every 6 minutes, I'm going to average every observation made in each of the 12 months shown here into a single value. So here again, I've kept the same y-axis so we can see where our average water level is relative to mean lower low water. We can also barely see, the red arrow points to that in the winter, water level is just a tiny bit higher. Average monthly water level is a tiny bit higher, maybe on the order of a foot or so, half a foot on average. But we're still only looking at a year here, and we still can't see sea level rise. Finally, what I'm going to do is I'm going to zoom out and show you all of the monthly average water level data collected in Seattle, dating back to 1898. So here I've compressed the y-axis a bit, just so you can clearly see the summer-winter cycle here that I showed you in the last plot. Here it's bigger because the y-axis is compressed, which gives this record its sawtooth appearance. You can also make out here an upward trend over time in monthly average water level. It's marked with the red arrow. And this is the change in average water level over these longer time frames, many years to decades. And this is what we are defining as sea level rise, the change in the long-term average water level. It's worth noting that in this case, we are making our measurements relative to land. They're made at a tide gauge, which may be moving as well. The land might be moving up or down, and we will get to that in a bit. But the key point here is that to understand the impacts of sea level rise, we really have to understand that all of the other variability and cycles that I've showed you, the daily tides, the summer and winter cycles, for example, are operating on top of this long-term trend. So our daily high tides are reaching higher up the beach, and events that lead to flooding are occurring more frequently. In other words, even though water level on our shores goes up and down every day by 10, 11, 12 feet, coastal communities in Washington can see and feel impacts from sea level rise that is measured in inches or feet. So next, How is sea level rise connected to global climate change? Well, climate change is a process that traps incremental bits of extra heat energy in the Earth system. So the consequence is that as more and more heat is stored in the Earth system through time, that has an influence on two processes that tend to be things we interact with on a day-to-day basis. So this figure is intended to illustrate these. First of all, we have the Earth here representing the Earth system. We have these two red arrows representing incoming solar heat energy and then outgoing heat energy. And climate change has the effect of trapping a little bit of the additional heat through time in the Earth system. And the two big processes that connect that to sea level rise are, first, if we expose ice to heat, it melts, something that we tend to interact with every day, if only through ice in our drinks. We are particularly concerned when it comes to sea level rise about land-based ice, or ice that is perched on land. And the arrows here are referencing two of the biggest masses of land-based ice on the globe. This one points to Greenland, and this one points to Antarctica. And as those large masses of ice melt, as the Earth system accumulates additional heat energy, they add new water volume to the ocean basins. The second is that as water in the ocean basins warms over time, it expands. Again, a process that we interact with, if only through our hot water tanks in our houses, which tend to have some mechanism, an expansion tank or an overflow designed to deal with that expansion of water. So again, something that we interact with every day. We also know that both of these processes are currently observable. For example, a satellite mission launched in 2002 allows us to actually measure changes in the mass of ice in Greenland, for example. This is an animation published by NASA based on data from what is called the GRACE satellite mission. And the satellite mission is able to measure changes in mass of the ice that's shown here in map view, and also as a time series over here. And you can clearly see the downward trend in mass of ice in Greenland associated with it melting. And again, contributing new water to the ocean basin. So again, both of the processes that drive, that connect sea level rise to climate change are currently observable. So finally, let's look at what we can expect in Washington State. So first off, it's important to note that we are experiencing sea level rise in Washington State. We can currently observe it. I showed you previously the record from the Seattle tide gauge, but as I noted, tide gauges can be influenced by movements of the land. Well, if we remove those land movements and their influences from Washington's tide gauges, what we see is something like what I'm showing you on the screen. And this is both annual average water level dating back to the late 1930s in the thinner line. And then the dark line is a 20-year rolling average, just to give us a sense again for that long-term average water level pattern. And hopefully what you see here is an upward trend. Again, this is land movement removed. So this is what the ocean is doing. And we can identify a pattern of sea level rise of about 4 inches over this 60 to 70 year time period shown in this plot. So again, sea level rise is occurring in Washington State. What do we expect in the future? Well, currently the best efforts to work out how future possible emissions translate into additional trapped heat and then turn into future ocean expansion and melting ice point to a future of additional sea level rise, and at accelerated rates. There's a good deal of uncertainty in trying to assess the future, though, in the same way that there might be if we were trying to project something like population or economic parameters over that same time frame. However, the approach we used in our 2018 assessment uses what we refer to as a probabilistic framework for communicating our current best estimate of future sea level. This is based on work published in 2014 by Bob Kopp. And on this plot, we have time on the x-axis down here out to 2100. And then we have change in sea level in feet relative to essentially our turn of the century average sea level. And what you can make out here is a variety of curves that are sea level scenarios. And each of these has a percentage associated with it, which is an assessment of likelihood. So for example, if we were interested in what we expect to be what we currently assess to be our most likely 2100 sea level scenario, we would focus on the dark black line here, marked with the 50th percentile. Somewhere just north of 2 feet of sea level change by 2100. However, this also tells us that that amount of sea level change can't be excluded as a possibility much sooner, right here around 2050, but we currently assess that they have a much lower likelihood or possibility of occurrence. However, as I noted earlier, the land may also be moving, and that affects how a community will experience sea level rise. So another major part of our 2018 assessment was a vertical land movement analysis, the results of which I'm showing you here for coastal Washington, expressed in feet per century, with the hot colors being areas that are uplifting and the cool colors being areas that are subsiding. And if you are interested in your particular location, we also have an online interactive tool that allows you to select a coastal location in Washington and easily extract sea level projections for your location that integrate vertical land movement, again, across a range of likelihoods and also for 2 different greenhouse gas emissions. That is available at the WACoastalNetwork.com website. This is the website for the Washington Coastal Hazards Resilience Network. And at that site, you'll also find a variety of other sea level rise planning tools and guides. So it is intended to be one-stop shopping for sea level rise planning for coastal Washington. So with that, I wanted to thank you. And again, direct you to WACoastalNetwork.com or Google search Washington State Sea Level Rise to find this report, the 2018 assessment that I've referenced, and other sea level rise information.